Welcome everyone. Today we are going to discuss measures of dispersion. So first of all, what is measures of dispersion? Before we have seen what is measures of central tendency. The central tendency gives center or average or the representative measure which defines for your data set. And here this dispersion defines how far these actual observations from your data set from the center. That means this dispersion gives the degree of deviation or the spread of our actual observations. That means if we have identical observations as our sample, our dispersion is going to be 0. Means what? If consider one batsman is there and he is playing consistently 100 for 3 matches, then it is said that there is no dispersion and the deviation will be 0. The dispersion value is going to be 0. If we are saying dispersion value is low, that means the actual observations are more close to the average. Means what? Consider another player is there. He played 55 runs in first match, 50 runs in second match and 45 runs in third match. That means on an average his run scores are 50. This 55 and 45 more close to that 50, more close to the average, and hence here this average of dispersion value is low. In some cases, if consider another example, a player is playing 50 in one match, 0 in another match and 150 runs in third match. That means again that player is having actual observations far from the average. The same average value will be 50 itself. Okay, that means the dispersion gives the consistency of our observations or the continuity of our actual observations. The measure of dispersion provides, it is another one indication regarding summary statistic, such as if we are describing the central tendency gives the representative of our data set. The same thing, dispersion gives the spread of our or the nature of our distribution, which is used for univariate statistic also. There are 3 main types of dispersions. What are they? First one is range, another one is semi-interquartile range, which is known as SIR also, and the third one is variance. Instead of variance we can use another term, standard deviation also. Both are different terms, but we can see them as one along another. Okay, so first one is range. What is range? Range is nothing but the difference between maximum observation to minimum observation. It is defined as XL minus XS. X is nothing but the notation of our observation. XL means the largest observation, maximum observation. XS means the smallest observation. So here we can define R is equal to XL minus XS. Now we will see one example. For this following data set observations, we need to find out the range. So here observations are 4, 8, 1, 6, 6, 2, 9, 3, 6 and 9. So among that, what is the maximum observation? So maximum observation is having maximum value. What was that? Here this n, that is 9, is the maximum observation and 1 is nothing but the minimum observation. So the difference between them is nothing but the range. Okay, so follow this. The largest score of this given example is 9. The smallest score of this given example is 1, and hence the range can be calculated as 9 minus 1, 8. Next part is semi-interquartile range. Semi-interquartile range is nothing but the range, average range between first quartile and second quartile. Before we start this quartiles is nothing but the observation which divides the whole data set into 1/4 part. There are 3 observations which are in quartile. First quartile, second quartile and third quartile. These quartiles are also known as partition values. Okay, partition values means what? Just consider here, this is our data set. The data set is divided or represented in this column, this bracket. This is what our total n data set, capital N data set. Okay, then the median value, measure of central tendency, is the positional average which divides the whole data set into 2 parts. Okay, so consider this as one median. This is our median. Median, what it does? Median divides the whole data set into 2 equal parts. Okay, then this first quartile, we can say this one, this is the partition which divides these two into 1/4. This one part is 1/4 and this one part is 1/4. Another part. Again one part is there, one partition we can make which divides the whole data set into 1/4 part. That will be, just call this as Q1. This median can be called as Q2. Q2 is nothing but the median itself, and the last one is Q3. Q stands for quartiles. Okay, so these 3 partitions make the whole data set into 1/4 part. 1/4 part like this. From the starting of observation to 1/4 part is Q1. Q1 to Q2, again it will be 1/4. Okay, that means how much area or how much observations before Q2, it is half, and how much observation after Q2, again it is 1/4 plus 1/4, that is 1/2 itself. So these are our quartiles. Okay, so here we are going to discuss the semi-interquartile range is between only third quartile and first quartile. Again I am telling, quartiles are those partition values which divides the whole data set into quarters, that is 4 parts. Same thing we can define deciles. Deciles are nothing but those partition values which divides our data set into 10 parts. Same thing we can do it with percentile. Percentile is related with making 100 parts. Percentage is 100. That is, percentiles are nothing but that positional values which are dividing the whole data set into 100 parts. That means we can define this SIR, semi-interquartile range, into its quartiles also as well as in percentiles also. So just consider that the first quartile is nothing but the 25th percentile. The third quartile, which is Q3, is nothing but the 75th percentile. Then this semi-interquartile range can be defined as Q3 minus Q1 divided by 2. Now we will see this example. The examples observations are being given as 2, 4, 6, 8, 10, 11, 12, 14, 20, 30 and 60. There are 10 observations. N is equal to 10. N is equal to 10. Isn't it? That means first of all we need to define the quartiles. Quartiles means first Q1 is dividing by 10 divided by 4. Second one is 10 divided by 2. And third one is 10 divided by 4 into 3. That is 3 into 10 divided by 4. That means here this 2.4 fifth observation, 2.5th observation will be here somewhere between these 4 to 6 part. Okay. By taking average of this 4 to 6, we can have 5, and this 5 is nothing but the first quartile. Then 3 into 10 divided by 2 will be given as 7.5, and it is going by these two observations. The average of these two observations is nothing but this 25. That's why they have taken 25. Okay, so that is 25th percent of score below 5 is 5, and second one Q2 is been defined like this. Therefore, semi-interquartile range as per the formula, what we have to write? 25 minus 5 divided by 2. Therefore, what is semi-interquartile range? It is 10. This is the final answer. Next part is variance. Variance is nothing but it is the average of square deviations. First of all, deviations means what? A deviation is nothing but the difference from actual value to the average value. Average value is generally taken as a mean. Okay, so the formula is defined as sigma square. This part is known as sigma. Call this as sigma. Sigma square is equal to summation x minus mu bracket square divided by n. This mu is nothing but the average is. So how to calculate this variance? First of all, we need to find out the difference, that is deviation score. Difference is nothing but we need to calculate this x minus mu score. X is nothing but number of variables x, x1, x2, x3 and so on. This deviation defines, that is these values are defining this x is how much far from that mu. That means if x is positive 1 greater than mu, the difference will be positive. If x is less than mu, the difference will be in negative 1. Okay, then this variance is nothing but average of that deviation itself. If we are calculating this deviation x minus mu, as we have discussed, if x is greater than mu, we can have the positive deviation. If x value is less than mu, we can have the negative deviation. That means if there is one result, addition of all deviations taken from mean is always 0. Okay, because mean is at center. That's why instead of taking only deviations, we supposed to have this square. Okay, to avoid this kind of problems of getting 0 as per the deviation, we are just squaring that part. Okay, this square function makes negative differences as positive one. We are just considering the positive part only. Okay, that is squaring the deviate score makes squared scores positive. All deviations will be positive, and hence variance cannot be negative. The first part is variance will be always positive. Now, what this variance formula mean? It is nothing but it is the mean of square deviations. Average of square deviation. That means if we are having larger variance, the actual observations are far away from the average. If we are having smaller variance, the actual average values are near to the mean. They are not far away from mean. Next part is standard deviation. Okay, standard deviation is nothing but square root of variance. Variance formula is sigma square. We just use the sigma notation for standard deviation. What is the relation? Sigma is nothing but square root of variance, and variance is nothing but the square of standard deviation. That's why we have used this oblique formula for the third part of. Now, what is the computational formula for this? When calculating variance, we are going to use two formulae. One is by definition, one is actual calculation. That means sigma square can be calculated by this one. This we have already seen. That is summation of x minus mu bracket square divided by n. Here mu is nothing but the mean. or we can call this as x bar. X bar is the notation for mean. Instead of that, we can use this formula also. That is, instead of calculating average, we can use summation of x square minus summation of x square. This x square is value square. This is total of x bracket square divided by n. N is nothing but total number of observations. Either we can use this first formula or the second one. Okay, so sigma square is known as population variance, x is observations or score, mu is population mean, or we can say mean average of this, mean of the observations, and n is nothing but total number of scores, total number of observations. Now we will see how to calculate this variance. First of all, these are the x values. X values are 9, 8, 6, 5, 8 and 6. We can calculate this standard deviation by using computational formula also and by using formula also. For that, what we need to define sigma square as summation of x square minus of x, the summation of x bracket square divided by n. N is nothing but summation of all that values. This is nothing but the summation of x. Then I need x square. Another column I have made, which is x square. 9 square 81, 8 square 64, like that. Then I have made the total, which is 306, which is summation of x square. Okay. Then how many observations we have? 1, 2, 3, 4, 5 and 6. That means our capital N, that value is 6 itself. Now first of all, we need to define the mu value also. So mu value is nothing but summation of x is divided by n, which we have already seen. It is a center mean defined by summation of x divided by n. We can calculate that it is nothing but 42 divided by 6. What will be this value? 42 divided by 6 is always how much it is? It is going to be 7. Then next column they have calculated that x minus mu. X minus mu means this values of x getting subtracted from 7. 9 minus 7 it is 2. 8 minus 7 it is 1. 6 minus 7 it will be minus 1. 5 minus 7 is equal to minus 2, like that. If I add only these points, which are the deviations actually, I am getting all zeros. Okay. Hence, to avoid such situations, we have find out the squared values. These are the squared values, and by using another formula, that is sigma square is equal to summation of x minus mu bracket square divided by n. This gives another answer. Now from both the method, this one is by first formula and this one is the second formula. Here you can observe that both the values are being same. That means if we are calculating variance from this one or this one, both are dividing the same answer.